Bismillahirrahmanirrahim. Uh, we will discuss signs of trigonometric ratios in four quadrants. This is included in AS level trigonometry. So this is very important to consider the signs. Sometimes the students learn by heart or they try to remember them. So I always encourage to understand instead of remembering the things with no understanding. So it's better to have a clear understanding about it, that how we can remember, how we can realize, or how we can understand that, uh, how we can consider the signs in four quadrants. So let's see, let's start the discussion. Then you will understand that initially we have done these three ratios, that sine theta is equal to opposite over hypotenuse, cos theta is adjacent over hypotenuse, and tangent theta is opposite over adjacent. This is the formal ratio of these three, and what I had recommended, that I asked that if you can remember it in this way, that this hypotenuse is common in these two. We will discuss tangent theta separately, so leave it so far. Let's talk about only these two. So this is common, hypotenuse and uh, in sine theta and cos theta. So what is the difference, and how you can remember them? So that is like these, you can have this thing in your mind, that sine theta is related to opposite and cos theta is related to adjacent. What you need to remember, that cos theta means adjacent and sine theta means opposite, because both of them have hypotenuse as their denominators. One thing, and second thing which makes an effect, that we have already discussed the angles in a grid, four quadrants. So if a line is here, if let's say the length of line is r, so wherever is it, it is positive. This is r, or if the line is here, this is r. So in whichever quadrant is it, it is always positive. So you can understand that the sign of sine theta or cos theta, sign does not depend on this hypotenuse, because it is always positive. So what the sign of these two ratios depend on, that is the sign of adjacent or opposite. Okay, if it depends on the sign of these two, then here this is positive x-axis, this is positive y, this is negative x, and this is negative y. And regarding general angles, positive angle or negative angle or reference angle or basic angle, whatever type of angle we consider, that is always with x-axis. We consider all the angles with x-axis. So that means when every angle is to be considered with x-axis, then x-axis plays the role of adjacent. That is always adjacent to the angle. And for every angle, y is always opposite to the that angle considered. Now, like in second quadrant, if this angle is considered, this is opposite. If we consider their directions, this is negative x-axis and this is towards positive y. So one more thing, if you look at it, if you consider that if we mark a point here, its coordinates, like this is 5 units and this is 3 units, 3 units and 5 units. What should it be, positive or negative? So obviously this is towards left, so this must be negative. So this point is -5 and 3. That means x coordinate is negative and y is positive. So always in second quadrant x will be negative and y will be positive. In the first quadrant, if there is any other point, let's say this point, this is if it is 6, then this point is 6, 3. X is positive as well as y is positive. Here we discussed that angle is always with x-axis. So wherever x is positive, cos is positive over there, and wherever x is negative, cos is negative there. So here we can see that x is positive and y is negative in first quadrant. This is positive x and this is positive y. As x is always adjacent, x plays the role of adjacent. So we can say that if x is positive, that means adjacent is positive. Further, if adjacent is positive, that means cos theta is positive. If y is positive, that means opposite is positive, because we have just now discussed that y opposite will always be opposite to this angle, and since for all such ratios angle is always opposite, this y is always opposite, so y is positive here, then sin theta is opposite over hypotenuse. So if y is positive, sin theta is positive. Sin is positive. In this case, from here you can see that x is negative. So directly relating it to cos or sin, so cos theta is negative here, and this is positive. This is y coordinate. If y coordinate is positive, that means sin theta is positive. Okay, if we consider any other point in third quadrant, if a point is here, then keep in mind that we are just discussing sine and cos. We will consider tangent later on. So this is, let's say, -6 and this is -4. This point is -6, -4. Now x coordinate negative means cos theta is negative and sin theta is negative. If there is a point here in fourth quadrant and its coordinates will be, let's say this is 5, this is 2, then 5 minus 2. So this is x coordinate is positive, that means cos theta is positive. Y is negative, that means sin is negative. Sin theta is negative. Whereas theta in this case, when we draw a line this way, this is theta here. So this angle, for this angle, you can see that this is downwards, that means negative, so sin is negative, and it is moving towards right, so cos is positive for this point. Once again I draw them separately. In the first quadrant, here is a point. If this is 5, 3, so this is 5 units this way towards positive. If it is towards positive, then cos theta is positive. If it is moving upwards, that means sin theta is positive. So we can decide about the signs of sin theta and cos theta by considering the direction of x and y. If a point is towards positive x, that means cos theta is positive. If a point is towards negative x, then cos theta is negative. If a point is towards positive y, that means sin theta is positive. If a point is such that towards negative y, that means sin theta is negative. Okay, further, if we relate them with this line, vertical line, this is y-axis. You know, for all the points on this side, whether which two quadrants are on this side of y-axis, that is first quadrant and fourth quadrant, then all the points on right hand side of y, they are positive. So cos theta is positive throughout, towards right. On the right hand side of y-axis, cos theta is positive, and on the left hand side, this way, everywhere, wherever is it, whether I have deliberately not drawn x-axis to differentiate between first and fourth quadrant, but whichever is it, whether it is first quadrant or fourth quadrant, but x is positive on this side, hence cos theta must be positive. And for these points anywhere on this side, cos theta will be negative. So now if we consider the detail of this is y-axis, y is x, cos is positive on this side, cos theta. Which two quadrants are there? These are first quadrant, first and fourth quadrant. Here for both of these quadrants, x is positive. So for all the points here, anywhere in one of these two quadrants, if there is a point anywhere, then cos theta is positive for that. And obviously when it is positive on right hand side, then it must be negative in all throughout this area. All this area on left hand side of y-axis, cos theta must be negative. So if I define it in words, I can say that cos theta is positive on right hand side of y-axis, or you can define same thing as cos theta is positive where x-axis is positive. Cos theta is positive on right hand side of y-axis, or you can say cos theta is positive where x-axis is positive. Both are same because cos theta is positive on right hand side of y-axis. As you can see that if this is y-axis, then this is right hand side of y-axis. So if I draw x-axis, so you can see that x-axis is positive on right hand side of y-axis. So wherever there is a point making an angle, this is a point making an angle with origin. So this angle, for this angle cos theta is positive because for all these points x-axis is positive, and on the left hand side then it would be negative. In the same context we can say that sin theta is positive where y-axis is positive, or you can say that sin theta is positive above x-axis. Once again, both the sentences have same meaning because y-axis is positive above x-axis. So if this is x-axis, this is x-axis. So above this, for all the points above x-axis, sin theta is positive, and below x-axis, for all the points below x-axis, sin theta is negative. This side sin theta is negative, and above x-axis that is positive. Okay. Now then I said that where y is positive, so you can see that above this line y is positive and below this line y is negative. Where y is negative, their sign is negative. Where y is positive, sign is positive. So I wish you to remember these ratios with the reference of sine x-axis and y-axis. Just think about a relation between cos theta and x-axis, and on the other side sine theta and y-axis. Wherever sine theta is positive, y is positive, or y is positive, sine theta is positive. Now randomly, if I write any point here like minus 5, 7, if this is a point on a grid, and if the point is joined with the origin, it will make an angle with x-axis. Then what will be the signs of x, cos theta and sin theta? If x coordinate is negative, that means cos theta is negative, and y coordinate is positive, then sin theta is positive. You can simply understand in this way. Okay, let's see if this point is marked in a grid. Let's say this is minus 5 and this is 7, 7, minus 5, 7. This is a point minus 5, 7. When this point is joined with x-axis, this is the angle made by the line joining this point to the origin. Then you can see that this is above x-axis, so sine theta is positive, and this is on the left hand side of y-axis, so cos theta is negative. So where x is negative, cos theta is negative. Where y is positive, sine theta is positive. So this way you can understand it. Okay, if we consider any other point like 5 minus 6. Now wherever is it, in whichever quadrant is it, but from here this is x coordinate, this is y coordinate. So x coordinate, we can see that this is positive, so cos theta will be positive, and we can see that y coordinate is negative, then sine theta will be negative. So what we have to do, you are supposed to relate x-axis with cos theta and y-axis with sine theta. If y is negative, sine is negative, x is positive, cos is positive. Now let's see whether it is in the same way or not. This is 5 and minus 6 means downwards, minus 6, and this is the point 5 minus 6, and if we join it to the origin, then this angle is theta. You can see now that vertical line is downwards. Downward means negative, so sine theta is negative here, and the horizontal line is towards right, so cos theta is positive. So in this way you can understand. Okay, now sine and cos, simply whenever you hear about sine theta or cos theta, I wish that you should have in your mind sine theta y-axis, cos theta means x-axis, and relate them regarding their signs. Where cos is positive, sine x is positive. Where y is positive, sine is positive. When y is negative, sine is negative, and where y is positive, sine is positive. And this way you can relate them without remembering that first quadrant, second quadrant, and third and fourth, and this and that. So in this way you can understand. Now we will come to tangent theta. Tangent, you know, tangent theta is opposite over adjacent, and regarding a grid, this is opposite and this is adjacent. So in the same grid, if we find gradient, that will be rise over run, that will be the same thing, this will be the gradient. That means you can relate tangent theta to gradient. Gradient of a line in a grid is actually tangent theta. So in this context, if you remember in coordinate geometry, we know that all the lines in this direction have positive gradient and other lines in this direction have negative gradient. So if you relate them to a grid, so the lines with positive gradient fall in first and third quadrant, first and third quadrant. So wherever gradient is positive, tangent is positive over there. So this is tangent is positive in first and third quadrant, and on the other side lines in this direction have negative gradient, so tangent is negative in these two quadrants. Tangent is negative. Now again, relating tangent to the coordinates, like if there is a point in first quadrant, this is in second quadrant, there is a point in third quadrant, and if there is a point in fourth quadrant, like 4 minus 3, third quadrant, this will be, both of them will be negative. So in this first quadrant, you know, y over x, tangent theta is opposite over adjacent, y over x, so it will be positive. And here that will be 5 over minus 2. In this case, minus 7 over minus 5. In this case, gradient will be minus 3 over 4. So one thing we can conclude, that where both the coordinates have same signs, both are positive, or in this one both are negative, then tangent is positive in these two cases. And where one coordinate is negative, then tangent is negative. In these two cases, tangent is negative, negative tangent theta, negative tangent theta. Here tangent theta is positive, and in this one again tangent theta is positive. In which quadrants these 2 points are? This point is in first quadrant, and this point is in third quadrant. This is second quadrant, and this is fourth. So you can see that first and fourth, one of the coordinates is negative, so the gradient in second and fourth, in second and fourth gradient becomes negative, and first and third gradient becomes positive. So once again, just to revise quickly, if you consider vertical line, not y-axis, cos is positive on this side, and it is negative on this side. Second, sine is positive above x-axis and is negative below x-axis. Below x-axis, if you draw an arrow downwards, then sine is negative. If the arrows go upwards, sine is positive. Tangent theta, this way the lines have positive gradient, that means tangent theta is positive in this one and this one. And second reason, that here both the coordinates are positive, in this one both the coordinates are negative. And if a line is this way, falls in second and fourth quadrant, its gradient is negative, so this is negative tangent theta. Here again negative tangent theta, it is positive here. So this is the way you can remember their signs. Now finally, I just, in the formal way, as it is mentioned, you know, sin theta is positive, cos theta is positive. Sin theta is positive for this reason, that y is positive. Cos theta is positive here for the reason that x is positive. And tangent theta is positive for the reason that y and x, rise over run or gradient, everything, they are positive. In this quadrant, sin theta is positive for the reason that y is positive. Cos theta is negative in this quadrant for the reason that x is negative. And tangent theta is negative for the reason that gradient is negative in this way. And here sin theta is negative, and the reason is that y is negative here. cos theta is negative for the reason that x is negative. X is negative, so cos is negative. Tangent theta is positive for the reason that gradient is positive this way. Here cos theta is positive. What is the reason? Because x is positive here. And sin theta is negative because y is negative here. And tangent theta is negative, and the reason is that gradient is negative here. So further summarizing it, we can see that only positive. So all the ratios are positive in the first quadrant, so all the ratios are positive here. And only sine is positive in this one because y is positive. So sine is positive in this quadrant, tangent is positive in this quadrant, and cos theta is positive in this quadrant. So you can remember, and this is not matter of remembering that sometimes it is suggested that you can remember CAST, cast, this word, or all positive sign this and that. I would prefer that if you remember in the context of x and y axis. Y axis is positive upwards, so sine is positive in these two quadrants. X is positive on this side, so cos is positive here. Gradient is positive this way, so tangent is positive in these two quadrants. So that's it. I have tried to explain in a different way. So I wish that if you remember them in the same context of x and y axis, I think then you can remember it for a longer time. So let's see, I hope that it would be clear to you. So thank you. Allah Hafiz.